Cook-a-man. All right, another set of Algebra 1, Semester 2, Final Study Guide Review. We're looking at questions 31 through 40, so let's get started. On this first one, we are trying to figure out which of the following functions has a graph with a vertex that's translated 3 units horizontally to the left of this graph right here. So if you remember, in vertex form, you have, this is really our x value, and this is our y value, h and k. So if I want my graph to go horizontally to the left, that means that I am moving it, my x value in subtraction of 3. The x value of this graph is the inverse of positive 1, so negative 1. Take away 3 is negative 4. Again, when I put this back into vertex form, I'm going to take this and change it to the opposite, which is positive 4. So I'm looking for any graph that has plus 4 in it. It does not want you to translate this graph. It wants you to find any graph that is translated. And that is why C is correct, even though it has the 2 for A. It's not identical to the one above. That's okay. For the next problem, we are trying to find the axis of symmetry of this function. So we're going to use the equation because the axis of symmetry is x. It's the x value, is negative b over 2a. So I'm just going to take the, well, that's if we're in standard form. We are in vertex form. In vertex form, it's a lot easier than that. We are taking the opposite of h and k. So it's positive 2, 1 is my vertex. X is the axis of symmetry, so my answer is 2. A lot simpler in vertex form. Number 33, we are, okay, this one a lot of us are consistently getting wrong, so let's remind ourselves about this one. Here. Okay, we are trying to find the rate of change. Rate of change is slope. Slope is y2 minus y1 over x2 minus x1. However, in vertex form, it's not y2, it's f of x. 2 minus f of x, 1. So I basically need to take these x values, plug them into my equation, and then put them into this equation here. So I'm going to do 2 times negative 4 squared minus negative 4 minus 4, and I'm dividing that by the x value of 4. I am then going to subtract that answer by 2 times 2 squared minus 2 minus 4, and all of this divided by 2. Okay, so again, I'm subtracting my f of x's, my y values, and I'm subtracting my x values. When you solve this, you should be getting 32 take away 2 over negative 4 take away 2. That becomes 30 over negative 6, which is negative 5. On 34, we're taking a look at this graph right here, and we're trying to identify the equation of the graph. If you look, our vertex is at positive 2, negative 1, positive 2, negative 1, which in vertex form, remember the x is going to be the opposite of h. So I know it cannot be E and I know it cannot be H because these are positive 2's, and in vertex form, I need it to say minus 2. Now I need to decide, is there a value or is there no a value? So what I'm going to do is take a look at the 2 values here that I can see easily that are on coordinates, and I'm going to plug them into the equations and see which one works. Okay, so I'm going to say, okay, what is the value of this equation when x is 1? Minus 2 squared. And what is the value when x is 3? Okay, so let's go ahead and solve that and see what we get. Okay, so when I solve the equations for this first function of f, I get 1 for each one, and that makes sense. When x is 3, y is 1. When x is 1, y is 1. I just did it for one of them in this equation for g, and you can see that when x is 1, the y is 0. So it cannot be g. It has to be f. All right, down here, 35, we now have standard form, and we're trying to find the axis of symmetry for this one. Now we're going to be using the negative b over 2a to equal x, and x is our axis of symmetry. So I'm going to take negative 6 over 2 times negative 1. That's going to be positive 6 over negative 2, which is going to get me negative 3, and that's my answer right there. Easy peasy. 36 is a little bit trickier. I know that we had something like this on a test previously, and we struggled a little bit. There are a couple ways to do it. I can set up my two equations and subtract the 2. So I can have x squared minus 3x, and then I can subtract them from each other. That's going to make my y's go away. I'm going to get my x squared, and then I'm going to subtract a negative, which is adding. Well, here, actually, let me flip-flop these around. It'll be a little bit easier to see here. So y equals x squared minus 3x, y equals x. Now if I subtract them, I'm going to be getting no y's, x squared is by itself, and minus 4x. From here, I'm then going to solve my problem, set it equal to 0, okay? I can solve with completing the square. I can solve with quadratic formula. There's lots of different ways to solve, but in the end, you're going to get 0, 0, and 4, 4. So I went ahead and did completing the square here on the left. So I had x squared minus 4x equals 0. I went ahead and did the completing the square with b divided by 2 squared and got 4. I added 4 to both sides of my equation, and now I have a perfect square trinomial. We're going to do the square root of 4 to get 2. Here's now my binomial squared is x minus 2 squared. I did the square root on both sides and got x minus 2 equals positive or negative 2. Split that into two equations with positive 2 on one side and negative 2 on the other, and we get x is 4 or 0. Now I'm going to take these and put them back into the equations to find the y values, and if you do that, you end up getting 0, 0, and 4, 4. All right, this next problem, 36, is super simple. We have a linear equation or linear function and a quadratic function, and we're looking at where the two meet. Okay, so here are your options down here, because I know that it kind of is hard to tell where exactly on this line these 2 points are intersecting, but your options are only 0, 1, which is here, 1, 0, which is here, or both. And the only place where the line and the quadratic function, the parabola, intersect is at 0, 1. For 38, we're looking at the coordinates of the vertex in standard form. So to find vertex in standard form, I'm doing the negative b over 2a. That's how I start. So negative 2 over 2 times 1 is negative 2 over 2, or negative 1. That is my x value, so already I know it cannot be a because x is negative 1. I am now going to plug negative 1 into my equation. 2 times negative 1 plus 8. This is 1 plus negative 2 plus 8. That's going to be 1 plus 6, which is 7, and that's how we get b. Okay, 39, we are factoring, prime factoring our radicand so that we can figure out all the perfect squares and get rid of them. So I went ahead and did my factor tree. I ended up doing 24 and 10, split 24 into 2 and 12 prime. 12 into 2 and 6, prime, and 6 into 2 and 3, both prime. 10 splits into 2 and 5, those are prime. So if I write my prime factorization, it's 1, 2, 3, 4 2s, a 3, and a 5. So here are pairs that get kicked out of the house. So I've got 2 times 2 outside the house, and inside the house I have 3 times 5. When you simplify that all together, you're going to get C, 4 times the square root of 15. And then the last one here that we have is we're finding those real world solutions. I'm going to look at every single option and figure out if they have 1 or 2 solutions. Now, for me, the easiest way to do that is to start combining like terms so that I can get it in standard form, because then I can use the discriminant. But what you'll notice is that once I start moving things, if I subtract 3 from both sides, they cancel out. If I add 2x to both sides, they cancel out. And I'm left with x squared equals 0. Well, the square root of 0 is just 0, which means that this has only one real solution. Whereas if I come over here to C, I would end up dividing both sides by 3, and I would get x squared equals 14 divided by 3, which means that x is positive or negative the square root of 14 by 3, which means that I have 2 solutions. Over here, 5x on both sides, gets rid of them, minus 2 on both sides. I'm again left with x squared equals 0. But on the right, if I combined minus 4x, I'm going to get 2x squared minus 2x minus 3 if I get rid of the 2 on both sides. And I now have something that I can factor out, and I'm going to get 2 or more here as well. Okay, A and B, and that's it. Good luck, and let me know if you have questions.